Okay, again here, integrate the following. What's the u? No, u prime, uv minus the integral of v du by parts. Okay, u is ln x, and the dv is equal to x to the power of 4 dx. Yes, find the du by differentiate the first part. Du equals the derivative of ln x, 1 over x dx, and integrate the second part. Integration of dv is v, integral of x to the power of 4 is 1 over 5 x to the power of 5, and then apply the pi parts rule, uv minus the integral of vd. The u here is ln x times 1 over 5 x to the power of 5. This is the u times v. Then the integral of v, which is 1 over 5 x to the power of 5, times what? The dv. Times, sorry, the du. uv minus the integral of v du. Okay, so the du, it's 1 over x dx. Now we can simplify this x with the power of 5. And we have 1 over 5 x to the power of 5 ln x minus the integral of x to the power of 4 dx. Okay, so 1 over 5 integral of x power 4 dx. The first part stays the same. Minus, what's the integral of 1 over 5 x to the power of 4? We just add 1 to the power and divide by the new power. So it's 1 over 25 x power 5 plus c. So this is our final answer. So here, integration by parts. The u is ln x and the dv is x to the power of 4. So we have logarithmic function and polynomial. Li, p, pt. But according to this word, the u will be L, which is lens or logs, and p here, which is x power 4. So the priority of choosing u is for ln. Okay, number 2, this for area between two curves. Number 2, question 2, letter A, would like to find the area of the region bounded by the given curves. Decide whether to integrate with respect to x or y. You have the option, guys, to graph or not. Okay, so it's up to you. When we have here two functions like this, y equals 3x squared and y equals 0 and x equals 3, you can graph a quick graph or informal graph. Like x equals 3 is a vertical line passed through 3, and y equals 0 is a horizontal line passed through the x-axis. Okay, and then how to graph y equals 3x squared? It's a parabola. Let's say when 0 for x, when x is 0, so the y is 0. So this is the first point. When x is 1, the y is what? The y is a 3. And when x is 3, the y is 27, right? So I mean that the 27 is here, and then connect the points will be a curve like this. This one branch of the parabola. So the enclosed region between x equals 3 and y equals 3x squared is this yellow region. This yellow region R. So find its area. Area is equal to the integral from A to B, the upper function minus the lower function with respect to x. So we're going to integrate with respect to 2x in this question. The upper function, the one here, guys, from what to what? The x-axis from 0 to 3. A is 0 and B is 3. The upper function is the quadratic one minus the lower function, which is 0. Y equals 0. Okay, y equals 0. And then dx. So I'd like to integrate 3x squared as 3 over 3 x to the power of 3, and then substitute from 0 to 3. Cancel 3 out, and the answer is 27. So the area here is 27. This letter A. Okay, also here find the area of the region bounded by the given curves. Decide whether to integrate with respect to x or with respect to y. Okay, so here let's try how to integrate and finding the area without graphing. Okay, without graphing. Because it's given as x equals 2y squared and x equals 4 plus y squared, we know now that the area is equal to, from C to D in the y-axis, the right function minus the left function. The right function minus the left one. Okay, but here with respect to y dy. So our integration is with respect to y. Now our goal is to know which function is to the right and which function is to the left. Right. Before we start here, guys, we have to find the intersection points. How to find the intersection points? Yes, we have to equate the two equations. 2y squared is equal to 4 plus y squared. And then combine like terms, like 2y squared minus y squared is equal to 4. So y squared is 4, and now y is positive or negative 2. Okay? The integration with respect to y. So the limits of integration starts from negative 2 and then it's at 2. Now, which function is to the right and which function is to the left? Yes, without graphing, we can pick any value between negative 2 and 2 for y, like 0, like 1. So if we let y equals 0, the first function x equals 0. The second function x equals 4. So the first point here is 0 and 0. The second point here is 4 and 0. So if we graph a quick graph, we have 0, 0, and here is 4, 0, right? So we have function, our parabola opens right like this, and the other one like this, okay? So we know now that 2y squared is to the left and 4 plus y squared is to the right. Okay, and then right here, 4 plus y squared minus 2y squared dy, and then subtract the integral from negative 2 to 2, 4 y squared minus 2y squared minus y squared dy, and then integrate 4y minus 1/3 y cubed by adding 1 to the power and divide by the new power, and then substitute from negative 2 to 2. When y is 2, so we have 8 minus 8 over 3 minus, when y is negative 2, we have negative 8 plus 8 over 3. Okay, so 8 and 8, 16, and the negative 8 over 3 minus 8 over 3 gives a negative what? 16 over 3. So we can add here. So we have 16 and then minus 16 over 3. It's 32 over 3. Okay, so the area here is 32 over 3. Okay, right, next question. It's limit 3. Yes, find the area of the region enclosed by the following curves. X1 is y squared minus 2 parabola, and x2 is y. This dashed line is y. Since the first function is defined as function of y, we will calculate the integral with respect to y. And when the question, the curves are given as x equals, so it's better to integrate with respect to y. And from the graph, from the given graph, it's clear that we have a function to the right and another function to the left, right? So what's the formula here to find the area? A equals from C to D, the right function minus the left one, dy. So the integral is with respect to y. Okay. What's the right function? Let's define first C and D, the intersection points here. Not clear on the graph, so we have to find the intersection points. Intersection point or points. How to find the intersection points? We're going to equate the two equations, like y squared minus 2 is equal to y. Okay. Yes, y squared minus y minus 2 equals 0. And then multiply 3 or factorization, y minus 2 and y plus 1 equals 0. So we have either y is 2 or y is -1. So from -1 up to 2. The right function is the line y equals x. So we're going to take y minus the left function. Yes, it's y squared plus 2 here, because negative is positive, dy. Now integrate with respect to y. You should write y, not x here. Okay, so 1 over 2 y squared minus 1/3 y cubed plus 2y, and this between -1 and 2. Finally, substitute 2 for y and then -1. Yes. When y is 2, so here 4 over 2, it's 2 minus 8 over 3 plus 4 minus. When y is -1, the lower boundary of the integration, so it's half plus 1/3 minus 2, and then calculate. 2 minus 8 over 3, okay, plus 4, minus here half plus 1/3 and minus 2. The answer is 9 over 2. So this area is 9 over 2. Any question? Any question? Any question? Fine. Thank you.